Hi, this is Sajjad, welcoming you to this video of Nuke Learning. In this video, I am going to explain about deep render files and deep compositing. The deep concept was originally introduced by Pixar Company, and after that, some studios started working and developing deep. Then Weta Digital Company started working Avatar using deep renders, and currently all major VFX companies are using deep files for compositing purposes. Usually an image stores the data of red, green, blue, and alpha channels. Deep images stores additional data of depth per pixel. If there are different objects in the scene, the deep image stores additional data of the depth per pixels. Then we know where the object is located in 3D when compositing. If we render different deep renders with deep data, then we can combine them without any holdouts or mattes, and they merge in true 3D space. If there are any change in our scene, we don't need to render all the holdouts and mattes associated with them. Deep is different than Z-depth, and it is not a geometry type like Alembic or OBJ, which we use in our compositing software for 3D compositing. We store deep data in different image format. EXR format is the most famous one, and almost all VFX houses uses this format to deliver the deep data. The first step in working with deep files is to import them. You read in deep images to Nuke with a deep read node, which is rather like reading in any other images with the read node. You can hit Tab and type deep read or load it from the left side menu. As I said, almost all VFX companies are using EXR format for delivering the deep data. We focus on this format too, but if you need to import another deep format, such as DTeX format, you need to set up Pixar RenderMan, Pro Server application on your computer and do some other operations. We don't go over it here. Locate the deep render files and import into Nuke. This is the shape of deep render files, and I can look through them. They are just like regular RGB files, but it has deep pass. From the viewer, I can switch to deep, and this yellow representation is the sign of deep data. Cruising my mouse over the viewer, you can see the RGB values that has 50 and 52 values, which are the position of each pixel in 3D world. To merge them, I can't use regular merge node. I need to use deep merge node. Use the deep merge node to combine the samples from multiple deep images so that each output pixel contains all the samples from the same pixel of each input. The order of connection is not important because deep merge node uses the deep pixel data to do the merge. By default, this node is set to combine, and as you can see, it is merging these two renders together. I also have holdout option that I can use as mask out. I can swap the inputs, and you see the results. The plus operation overlaps samples from the A and B inputs, which can be useful when recombining data after a holdout. You can check the Drop Hidden Samples box in the Properties panel to not include samples that are completely occluded by nearer samples whose alpha value is 1. You can filter out samples using the Drop Zero threshold control. Increasing the value removes more samples with very small alpha values, such as those caused by floating point inaccuracy. The metadata from control allows you to control which input's metadata is passed down the node tree. When metadata from is set to all, and there are keys with the same name in both inputs, keys in B override keys in A. The other tool in Deep family is Deep Reformat. This node is the Reformat node for deep data. You can use it to set your deep image's dimensions, scale, and so on. As you can see, this deep footage size is NTSC, and by adding reformat, I can convert the size to HD 720. Now I want to add background to the deep structure. If my background is in deep format, then I can simply use another deep merge node and connect the background. But here I have this sky footage, which is my background. Now I need to turn this deep structure into 2D. Let me introduce you its node called Deep to Image and put it after the Deep Merge node. Logically, I have the deep structure live up to this Deep Merge node, and after putting Deep to Image, the conversion happens and Deep turns into 2D, and now I can simply use Merge node and merge this construction over the sky background. Let me remove these nodes. As you can see these stretches, it's a sign of not matching formats and sizes, so I can use deep reformat after these deep read nodes. And put one for each read node. Or I can put one deep reformat after this deep merge node. Or I can put regular reformat node after this deep to image node. They do the same thing. And of course, I need to put one reformat after this sky too. To color correct the deep files, I can use Deep Color Correct node, and you can see it is just like regular Color Correct node. But it has an extra tab, which is Masking tab, and works pretty much like Deep Crop node, where you can use the sliders and these options to mask out the area to affect the Deep Color Correct node. The number of pixel distance from the camera to be able to work with this tab. I can put one for this file and one for this file and color correct them individually. Or I can put regular color correct node or grade node after this deep to image node. But putting color correct node here will affect both files at the same time. To reposition your deep render files, you can use Deep Transform node. This node has the ability to move the pixels in X, Y, and Z coordinates. Z option controls getting close and getting far from the rendered camera. As you can see, by increasing this option, it is starting to disappear. Actually, this tree is going behind the sand. If you connect a regular roto mask to the node's mask input, you can use it to regulate how much of an effect the depth transformation has in different parts of the frame. You can use the Deep Crop node to clip your deep image, much like the normal crop node. Adjust the crop box in the viewer in X and Y directions to define your crop area. Alternatively, define your crop area using the bounding box fields in the Properties panel. If you want to keep the depth samples outside the crop box, you can check the Keep Outside Bounding box. Use the Z near and Z far controls in the Properties panel to crop samples in depth. If you don't want to use either of these controls, you can disable them by unchecking the use box next to them. If you want to keep your depth samples outside of the Z range defined by these controls, you should check the Keep Outside Z range box. If I want to actually crop the sample of deep, I need to know the sample number in 3D. So load another node called Deep Sample, connect to the footage, and move the viewer widget called POS over a part of this tree. As you can see, this node is showing bunch of numbers. What I need is deep front and deep back. On the deep front section, I have numbers from 95 to 0. These are the distance number of this points in 3D from the camera. And 95 means 95 pixels, distance from camera. The lower number is 5. I think I am able to start cropping when I reach the number between 5 and 10. So increase the Z far option in deep crop will bring it back to me around 10.